Hello, everybody. Thank you
Hello.
for being with us. So we don't know if you are from the west or from the east. So it might be very early in the morning or very late in the evening or even during the night. So here it's 4 o'clock p.m. and thank you for being with us. And we are going to start our presentation. So let me find our presentation. So about the speakers, we are two of us today. So Olivier Claire, who is our product manager in charge of displacement sensors.
Yes.
And myself, Philippe Cartier, I am the sales manager for the company SCAIME. We will have the pleasure to give you more information about our range of displacement sensors for the next 45 minutes. Thank you for being with us, and let's start with this presentation. So before we really start, just a quick rule about the presentation. So your microphone is switched off. You have the possibility to communicate with us using this little button on the bottom side of your window, which will give you access to a window where you will have the possibility to ask your question, and we will receive this question, and we'll be able to answer you at the end of this presentation. So thank you for following this link. Okay, so we are very pleased to introduce you our new range of cable-activated displacement sensors called PTS and PTL sensors. So we launched this new range last January, and here is the presentation of everything you need to know about this range and everything you can do with this range, with examples of application that might be of interest for you. So this line of displacement sensors gives the possibility to measure from 0 to 50 millimeters up to 0 to 50 meters, which is quite a wide range. So depending on the lengths we have to measure, of course, the housing, the dimensions of the products are different. And we will go through that during this presentation. So first of all, about the key segments. So Olivier, can you tell us more about the key segments we are targeting with these products?
Yes, so segments, industrial automations, lifting systems, agricultural machinery, medical devices, railroad, and wood industry.
Okay, so these are typical key segments for us. We will give you some examples of these segments during the presentation. But of course, there are very probably many other applications that you may know and we don't even know for now. And we will be very pleased to answer your inquiries in these cases. So the most typical application would be what, Olivier?
So hoist monitoring, synchronized displacement, test machines, machine position control, and control and monitoring.
Okay, so let's go for the presentation for itself. So first of all, we know that there are many different names which are given to these sensors.
Exactly, Philippe. Displacement sensor, draw drawing, draw wire transducer, yo-yo pot, string pot, many names for the same sensor.
Okay,
in fact.
so it can be a little bit of slang. If I see yo-yo pot, it's it looks funny.
Yes,
but well, it's true. I have heard that in the United States, for example, they like this kind of names. Yeah. Okay, how does this work?
So it's a very simple technique design. There is a cable, stainless steel cable we can pull out of the sensor. And this cable is around the spool. You can see on the picture, just show you the cable go out, enter into the unit. The spool, attached to the spool, there is a spring, and there is another part is a potentiometer encoder. This part will give you the electrical signal to use it. And the spring is used to have a good stress of the cable, not have a sag, to be sure that our an accuracy of the measurement.
So the sag would be, for example, how do I say that? The arc.
Yes, arc, you're right.
Instead of measuring a straight line, the weight of the cable might arc the cable, and then you have a non-linearity of the measurement,
exactly,
which is due to that.
Decrease the accuracy. So we have a strong spring, so we have no sag, minimal sag, and we can keep a good accuracy.
The size of the spring is depending on the length of cable. So the the more lengths we have, the more strong are the springs.
Yes, or we can add many spring to have.
Or you mean we can add springs one after the other in the same machine?
Yes, Philip.
Okay. Well, I'm discovering things every day. Huh? Okay.
So we transform, in fact, the linear displacement on a rotating displacement, and connected to this, we have a potentiometer or encoder, and we have this electrical signal like 4 to 20 milliamps, 0 to 10 volts, so pulses output.
So if we add an amplifier board, so we can amplify this signal and provide a 0 to 10 volts or 420 milliamp. Huh?
Exactly. We can put inside the sensor this electronic card, and directly you have the good signal 4 to 10 milliamps to go to PLC, for example.
Okay, so it's completely transparent for the customer.
Exactly.
Okay. And so for full stroke, from 0 to 50 millimeters up to 0 to 50 meters.
Okay.
So here we have some pictures of how these sensors look like inside the box. So maybe you can show us. So here we have the spool around the cylinder.
On the right part, you can see for example, yes, thanks.
I give you the mouse.
Yes, there is a spring in this part, this side, opposite side. Here they have, for example, a potentiometer, encoder, and electronic card if it's needed.
If necessary.
Yeah, we can see the same here with a different dimension, the spool, the cable here. And here there is a system, the sensor here is attached. The cable is fixing in this part. If we move this part like this, we have an electrical signal is proportional to the displacement. For example, you can see on the display the value. Very simple, very easy.
So it's very simple to install.
Exactly.
It's very simple to align, because you don't need any specific mechanical thing. So the spring pulling on the cable means that the whole, from the point of the sensor to the point the cable is attached, we will have a straight line, and the cable will go in and out of the sensor.
Exactly.
And the potentiometer or the electronic board will provide the right signal.
Exactly.
Okay. Sounds simple.
Yeah.
Okay, so let's talk about the range for itself. So we have actually two mechanics. So we have the PTS, which is the lower range.
Yes,
smaller range.
Small range. The maximum in this series, the maximum full stroke range is 6 meters.
Okay.
Yes, and for this series, you can have the final letter A for analog output. So analog output, it will be directly potentiometer, or with electronic card, voltage output, 0 to 10 volts, or milliamps output, 4 to 20 milliamps. With the letter I is for pulses output. And with the letter M is for mechanical. For us, we can adapt the encoder of the customer directly on the mechanic of the sensor. So we just sell this part, mechanic sensor, and the customer or SCAIME can fix or mount this encoder directly on the sensor.
So we will talk about that in some slide later,
yes.
Because there are some specific things to be known about this possibility. Okay, so this is for the PTS line, and then we have the PTL, like long range.
Exactly.
PTL-A, PTL-I, and PTL-M, just like we have the PTS-A, SI, and SM.
Exactly. We have the same logic with A for analog output, I for pulses output,
Increment.
increment, yes, M for mechanical, and we can connect the customer encoder directly on the units.
Okay.
And with this range, we start on 0 to 10 meters, and we finish to 0 to 50 meters.
So with these two subfamilies of products, we cover the full range from 10 millimeters range up to 50 meters.
Exactly.
50
yes.
millimeters.
Yes.
So that's pretty simple. So as we see here, the accuracy we can get from encoders is usually a little bit better than what we can get from pure analog systems.
Exactly, yes. Because there is potentiometer inside, and the linearity of the potentiometer is not less than 0.1%.
Yeah.
But with encoder, we can increase in fact, 0.01% is possible too.
Which, well, I mean, 0.1% can be enough for many applications.
Exactly.
But when you really need to be accurate, then the solution, including an encoder, is always better.
Yes, you're right.
Okay. All right. So two sub-range, PTS, PTL. So let's go a little bit more in depth to see how this works. So about the PTS series, we see that in terms of dimensions, we are on a dimension which are reasonable. So the main dimensions, it's ABC, so 110, 49, 25 millimeters. So it's reasonably big. So what are the main characteristics that we can observe on these sensors?
Okay, so it's a part of our data sheet. So all the information are on our data sheets, no problems.
And the data sheet are on the website, of course.
Exactly, yes. So we can see the accuracy, we can see the spring force. It's important, we said just before, that we be sure that there is no sag. The strength of the cable is perfect line.
Yeah.
So for accuracy, so we can see that this force is not too enough, but sufficient to be sure that the cable is always straight, no sag.
So that explains why, for example, for 6 meter, we have more force to keep the cable straight than what we need for 50 millimeters, for example.
Exactly, you're right. We can see that accept big acceleration. For example, you have the value here. The body is in aluminum. We have an option if it depends if it's outdoor application, we can make a complete anodization of the aluminum for resistance for corrosion, for example.
So it's a hard anodization.
Yes, you're right.
Yeah, it's a strong one.
Strong.
Okay.
The cable, we can see this cable output is stainless steel.
Yes.
And as Philippe already explained, there is a 5 range of units. So 5 dimensions, it depends of the full stroke range.
So with these 5 different models, we cover all ranges from 50 millimeters cable, the measurement range up to 6 meters.
6 meters, you're right.
Okay.
Exactly.
So that's pretty simple. Let's have a look to the PTL.
So we can find exactly the same specifications. You can see accuracy, spring force, acceleration. Material is the same possibility for hard anodization, cable range. Just we speak just before, for the big range, we can see there is many springs. So the body is more important to be sure that the same result, the cable will be straight every time, so to keep the good accuracy.
Okay, so the more tension you want on the cable, if your sensor is measuring let's say up to 50 meters,
yep,
you add springs in parallel,
exactly,
so that your return force is bigger.
Is bigger, yes, to be sure. Okay.
And as we can see here, we see that we start at 12, let's say 12 Newton for 10 meters, up to 20 Newton for 50 meters. So
exactly,
the longer is the range, the bigger needs to be the
spring. Yes.
Yeah, the spring. Okay.
Yes. And we can see that, for example, for 50 meters range, the length of the unit is less than 500 millimeters.
Yep. Okay.
So not too big.
Yep. That's pretty clear. Thank you for these explanations. So about accessories, because there are many things we can do around the sensor to let it work in good conditions.
Yes, to facilitate the customer to fix the cable.
Yeah.
At the end of the cable, we can have this steel of system. Eyelet is like a ring or washer. There is a hole. You just need to put, for example, a screw to fix it, or directly the system. There is threaded system, M4 or M6. It depends on the model. Or
So
another system.
Yeah, it's under the choice of the customer. We have both systems.
No, M4 is for PTS,
okay,
and M6 is PTL. Exactly.
Okay.
Or another principle is a screed. There is a system we can unlock this part, and this axle is go out. You can put for this steel system inside, and you put again the axle, and you can lock the system to be sure that everything stays in the good position.
Okay, and that there is no risk that it's dropped for whatever reason.
Exactly.
Okay, so if we need to have an angle for whatever reason, so we have the possibility to offer pulleys.
Exactly. To facilitate the system to the customer, there is a pulley where the cable can turn or touch this part, no problem. Here it's the pulley.
Yeah.
You can see the sensor, for example, on this picture. The moving object, you can attach the cable, and you can see that this part. So we can have not a big angle at the output of the sensor.
So it's always important that the wire is
more aligned.
Yeah, it's perfectly aligned with the output of the of the system.
Okay. We did not need a perfect alignment, but better it is. It is better.
Clearly.
We have a possibility to insert the pulley directly on the sensor. Here, it's integrated into the sensor.
So it's an option of the sensor.
It's an option of the sensor
if
needed. Another system is a magnet, very simple. If the system moving is a metal part, we can put the magnet directly here, and we can fix the cable like this, for example, directly on the magnet here. And we can see here.
So, for example, if the customer, for whatever reason, cannot drill a hole inside the structure which is moving,
exactly,
and if it's metallic, magnetic, in that case, so we can put this, and the Titan force of the magnet
is sufficient to
up to 22 Newton, I guess,
yes,
for the larger strength.
Exactly.
Okay.
Right.
So that's simple. Okay. What else in terms of accessories?
So extension cable, you can see this part, for example. So we have the sensor here, extension cable, and the system we fix into the cable. Why? Yeah. It is just to move away from the system. We can imagine in this part there is a high temperature, for example, 200 degrees Celsius. So its damage is dangerous for the sensor.
Yeah, the sensor would not survive. So
exactly. So we can move away the sensor from, for example, 1 meter.
Yeah.
And the sensor, the temperature will be acceptable for the sensor.
Or even more. It could be 10 meters, for example. Or...
Yes.
Mm-hmm. Then there is a question maybe with the spring where we need to be cautious with the force of the spring.
To be sure there is no sag.
There is no sag, yeah.
Okay. There are no problem.
Okay.
Another possibility, we can imagine that there is an application where there is a humid condition, so humidity inside the sensor. It is not a problem. The humidity is on this part. Normally there is still no problem for electronic part.
Mm-hmm.
And if the temperature decreases under 0 degrees
Celsius,
the problem, Celsius, sorry, yes. Problem, it could be freezing inside, so there is ice and they block the system.
You mean when you pull on it, it's going to restrain the cable, and then you break it?
Yes, or the cable is impossible to go inside the sensor.
Yeah, one or the other. Yeah.
Yes. Mm-hmm. So we can add this block. It is a resistance to maintain a temperature up to 0 degrees to be sure that there is no freezing inside the sensor.
So it's a regulated temperature?
Yes. Just 3 plus or 3 or 4 degrees, it's enough. Okay.
just enough to make sure it doesn't freeze.
Exactly. There is a thermos system.
Yep.
System, a regulation is automatic.
Okay.
No problem.
All right. So it's clear that in some countries in the winter it might be of interest. Huh?
Yes, or if outdoor application
Outdoors
too. Yes.
Also, yeah. Okay. So let's list the advantage of the PTS and PTL range of sensors. So first of all, we have a very wide choice of measuring ranges. So as we said, we start at 0 to 50 millimeters length, and we can go up to 50 meters range with approximately 12 different models between PTS and PTL to cover all this range. So that's a good comprehensive solution. It's a mature technology. We are selling this this kind of product for more than 30 years, and we have long experience with this kind of system, with this kind of systems, which are reliable. They are mechanically now well controlled, and it's clear that it's a technology which has proved in the past that it was very interesting to use, cost effective for many different cases of applications. In principle, this kind of product is very easy to install because what you need is a location to fix the sensor, a location to fix the end of the cable, and between the two, you will have a linear movement, and the system will self-align. Okay, to the exception of the sag error, but if the choice of the sensor and the spring that comes together with it is well done, and Olivier is there to help you defining the right technical solution, there is no nonlinearity error or very limited. So that is something we can master pretty well. It is also an interesting technology because it can easily be installed on existing equipments, even if it has not been designed originally to hold this kind of sensor. It's very easy to install. So for revamping or improving existing installation, that's really a good solution. And the number of cable lengths or the displacement ranges we have is such that even so, thanks to the industrial organization we are able to supply these sensors, whatever is the model you want, whatever is the option you want, within a very short manufacturing time. So as a standard, let's say a few weeks. And I think you said that even when sometimes it's even quicker, we can do
1 week.
1 week.
Yeah.
Okay, with special service in that case?
Yes, or less, in 3 days. It's a specific service with overcost, but it's possible in 3 days to manufacture and to send the unit. Okay.
All right, so that means that it's pretty flexible, and it might help you or your customers to find quick solutions for their applications. Okay, so we can also provide electronics to display the measurement. So what can we say about that, Olivier?
Very simple panel indicators. We have 2 models, the PAX D for analog input, so and the PAX I for pulses input. So it depends on the sensor. We can provide sensor with analog output or pulses output. So the choice it depends on the sensor output.
So resolution is what, plus or minus 2000 digit? No, is it?
Oh, more than that. There is a 6 digit.
Okay, so which means that we have far more resolution than the accuracy of the product.
Okay. The sensor, okay. Yes. So,
but it's a rather slow indicator, as far as I know.
Yes, maximum is 20 measurements per second. So it depends. The applications, sometimes we need more quick.
Yeah, if we have accelerations or deceleration, that might be interesting sometimes to have an electronic which is quicker. Exactly. And the good news is that we have some quicker electronics.
Perfect.
Yeah, good news.
Yes, exactly. We have this electronic. The main difference is what we just said just before, high-speed indicator. This indicator can make a measurement, 1000 measurements per second, and you have a detection of max value automatic. it's possible.
It has a peak hold function.
Yes,
Okay.
function.
Up to 1,000 measurements per second, you said.
Yes,
Okay.
and we can connect also this unit to a PLC.
Yep.
And with a specific software, we can catch all the data after.
Okay.
Recorded.
And so the GM80 exists in two versions. One is a panel mount.
Panel mounts, and another is a portable with a battery inside.
Okay.
So you can move with the sensor on different places of the warehouse and make different measurements.
Okay. So well, that's neat. Other solution.
A solution is a system we directly connect to the PLC. We need a PLC connected to this unit. We connect the sensor. We have from 1 to 4 inputs, and we can see on the screen of the PLC the numeric value we can, or the curve. It's a choice, both or one or lot or another. And at the end, if everything is correct for you, you can record all the data on your computer.
So it's a bit more sophisticated product. And,
exactly.
And you said about the speed?
The speed, if it is 5,000 measurements per second.
So it's even higher grade than what we can do with the GM80.
Exactly.
Okay.
And we can mix with the input card. We did another measurement for load cell, for example, force sensor, torque sensor.
So, okay, because we have different input signal that can be accepted.
Exactly.
Okay.
And this one is very specific for force or torque and displacement. So in general, we have the force we can see in this axle, vertical axle, and horizontal axle, we have the displacement, and we use this pair of two measurements for press application.
Okay.
So we have in the same time the force and displacement.
Okay, and so we have a graphic on the front panel of the indicator.
Yes, exactly, and the indicator can make different tests, and after give if it is correct or not, if the measurement is good or not.
Which means that we can program a specific ABAC inside the indicator.
Exactly.
So that you need to have a certain max displacement for a certain max force, for example.
Peak detection, etc. Okay. Yes, and after
So it's more sophisticated, and here we can go up to which speed?
4,000 measurements per second.
Okay. I have seen that you are not totally sure. So.
Yeah, sure. Sure.
Okay. He knows
a small hesitation with the first one before, but I am right.
Okay. So what's next? About the service we can offer. So we have a bench which is linked to our national standards in length. So we are able to make calibration for cable-activated sensors from 50 millimeters range up to 50 meters range, or even longer. But we don't need it because our sensors don't go any further. So this system is pretty interesting. It's connected to our national standards. As I said, we can go from 50 millimeters to 50 meters. And the measurement uncertainty is down to 10 micrometer, which is pretty good compared with the accuracy of the product. So we are far below the requested accuracy for the sensors. So this service is available for either new products or maybe product that you would have already at your in your companies or at your customer companies, and we can get them back and provide you a recalibration certificate every year if you like. Okay, so we have gone through all the different aspects, technical aspects of these products. Of course, more information is available from our website and our data sheets.
Exactly.
So what about the application? We would like to give some examples. So here is the first application. It's a dam. If I see it well. So
yeah,
what is the application?
Philippe. So it's a hydroelectric power system. So there is a motors, a turbine, and generators. We provide electricity for this. We need flow water, and to regulate this controls this electricity. There is an input gate here.
Yeah.
We can down and up and control the flow of the water. And the sensor is connected to the gate, and in real time we can monitoring this gate to be sure that there is a good power output.
Okay, all right. So that's a simple way to regulate the flow, and,
yes.
and the power of the system. That's
So,
very similar.
Yes, very similar. It's the dam. We control the level of the water.
Yeah.
In this application, the sensor is outdoor. You can see like this, for example.
So
yes.
just by the big jacks.
Yeah.
Mm-hmm.
And the main interest of this unit is when you close completely the door. Sometimes there is some tree trunk, something like this, and the gate block, and it is impossible to close completely.
Yeah.
So with this sensor, the operator has the information that the gate is not closed completely
closed. Mm-hmm.
And he can make some intervention to correct the problem.
Okay, understood. Okay, so here we are more in the wood industry. Yeah?
Yes, you're right. So the sensor can give the position of the tree, for example, and after the saw can make the cut. And in this kind of industry, there is a lot of dust. So to prevent the problem with the dust, you can see on this unit here, just here, there is some brushes, and the brushes can cleanse the cable when you go inside the sensor, to prevent that the dust go inside the sensor and makes some mistake for the
even more than mistake. You can break the cable that sometimes
it could
you
be, yes.
pull, and if you have some dust which is glued on the cable inside, then the machine will carry on pulling and break the cable.
Exactly.
Mm-mm. Clear. Okay, well, that's a good solution.
Here, the specific application with the unit, in this application, we don't need to measure the displacement, but the speed.
Okay.
So the unit is at the bottom. We attach the cable at the cabin, and when they move, the lift, with pulses output and with indicator, we can have on the display the speed of the system. It is to control the brake of the lift.
Okay.
Very simple.
All right. So, so for example, it could be used together with one of our indicators with the
PAX-E, for example, PAX-I. Sorry.
Yeah.
You can connect together, and on the display of the PAX, we can see
you will read directly the speed.
Yes.
Okay. What about? Sorry, please.
The application is to control the airflow for laminar cabinet, for example. It depends on the application, or if you open and close this door, we need to change the flow, okay? And so the sensor is connected inside. In real time, we can know the position of the flap to close or not the flow of the air. So you can regulate.
So in other terms, if the operator would open the door, it will require more flow.
Yeah.
And then it will give the signal to the little controller of the engine that
the flap, and they can move the flap in a good position, as the sensor checks that it is on a good position.
All right. So that's interesting application. So this is very much used in laboratories, medical industry.
Yes.
Okay. What about lifting applications?
So lifting application, we have a lot of application for overhead crane, lifting platform, or loader crane. So the system, there is an operator when we move the container. He doesn't know exactly the position of the container. It could be dangerous. So with the sensor, we connect it, for example, like this to this part. He can know perfectly what is the position of the container to move for more security.
Okay.
Okay. Or another application, if we have a lifting platform, for example, it depends on the weight on this platform here. In function of the weight and the position, so the sensor can give the position, for example, here with the jack, the position. It's forbidden to make some movement in function of the weight
for security reason.
Yes,
Mhm.
to control, to be sure that there is no system. We what can you say it? We can have some difficulty if the system is not stabilized. It can fall down.
Yeah. So we don't
very dangerous for
Yeah.
everybody.
Of course.
The
Mhm.
person inside or the person around the system.
Yeah, of course. Mhm. Okay. Okay, and on the right side we see some images here. It's same application.
Yes, it's very similar to
Yeah,
the first one.
to the
yes.
other. Okay.
Yeah.
Okay, so this one is different a bit.
Yeah, same principle to move a load, but in 2 points. Okay, there is two cable. We can say we lift the load. The problem, if one is the system, there is a motor, the wrench. If one start before the other or not at the same speed,
so, problem of stability.
yes, there is an unbalance, and it could be very dangerous. The load can fall.
Yeah.
So with this information, for each system, there is a sensor cable, displacement, and with this information, the PLC can synchronize the displacement, the filling.
Okay, so it will equalize the way it lifts on both sides so that it remains flat.
Exactly, horizontal.
Horizontal.
Yeah, you're right.
Okay, interesting.
Very
pretty similar here.
Very similar, yes. It is a train, for example, for maintenance. There is 4 systems like this. You can up or down the train, complete train. And there is a sensor inside this part for on each point. And all the information is on the PLC, and the PLC can say if they move in the same time at the same speed. And if it's not the case, it can synchronize all the system to be sure that there is no damage on the train.
So the 2 sensors go to the PLC, and the PLC is synchronizing the engines which are lifting the system.
Exactly.
Okay, that's an interesting application too.
Very similar, but here is a bridge in France. Okay.
It's by Bordeaux, is it? Or?
Yes, just near Bordeaux. You're right, the town Bordeaux in France. And we can see the height is 48 meters. So we sell in this application 40 meters full range. And there is 4 points to lift the systems. Okay, but we can see 8 sensor displacement. Why? We double the measurement for each point. It is for redundancy and for safety, for security. To be sure, if there is one sensor, it doesn't work, we can perhaps make one system up and down, and after it stops, you have to have a person we check what is the problem for security.
Okay, so as far as I remember, this bridge was made like this because Airbus is delivering parts of planes, and it couldn't go through a normal bridge, so they had to make this kind of bridge to let it go.
Yeah,
so
you're right, Philippe.
Big one. Okay, what is it here?
So we have an automatic system. We adjust the lifting table. So the PLC said we need to change the position about, I don't know, 1 meters, but I want to be sure that there is 1 meter. So the sensor is connected like this and like this.
Yeah.
So the jack move, and when the sensor gives the information 1 meters, the PLC can stop the system.
Okay.
There is a control and monitoring
system. So that's pretty simple.
Yes.
And, I mean, the sensor is easy to install, so it's a good solution. No?
Exactly, yeah.
Okay. Okay, we still have more application in the medical application. Oh, that hurts.
Yeah. It's for mammograph, yes. We developed for this case a specific sensor for the customer, yes. And this sensor can measure the gap between the 2 plates. They move independent of the person. And with this parameter, with the distance in measuring, the system can have this information and can adjust the fixture to take a good picture of the person.
Okay, but if the cable breaks, it does it like that, or?
I hope no. I hope no.
I prefer not to know. Okay, we are also in military applications.
Yes. So for this one is a moving bridge on the track, and when you stop, and there is you can imagine a army vehicle we move on this bridge, and the weight of the vehicle can up to sorry 30 tons.
Mm-hmm.
So it will be dangerous if the ground is not correct. So there is some stabilizers. Okay, like this. There is 7.
Mm-hmm.
So one is go down, touch the ground, and the jack move, push. And we sell in this application force sensor and displacements. And in function of the force and the displacement, the operator can know if the ground is correct or not. The harness of the ground is correct or not. If it's correct, no problem. If it's not correct, you have to move to change another place. Yes.
Okay. All right. Interesting. We have some application in the railroads monitoring.
Yes. So the machine move on the rail, and there is 2 skate. We touch the rail.
Mm-hmm.
Okay. Attached to this skate, there is 2 sensor.
Mm-hmm.
The sensor can give the position, the height of the rail for each, and the PLC compare in real time if the distance is the same, so the height of the rail is similar, and if there is a tolerance, if it's okay, no problem. If there is a problem, the difference is too important.
Yes.
So it's forbidden that the train can use this rail, and
Mm-hmm.
there is maintenance to make some operation to correct the problem.
So I think that on this machine there are plenty of sensors on one.
Yeah.
Maybe 12. Okay,
Yeah.
12 sensors. So they make all the measurement on a piece of rail. Huh?
Yes, you're right.
Okay. What about agriculture applications?
So agriculture. So we need, it's important now for us pollution. So we need to reduce the products that we spray on this, and to be sure that we waste less product. So it's important to know the gap between these 2 spreaders.
Mm-hmm.
It depends. It can change in function of the grapevine. So with the sensor, we give the position of each spreaders, and the operator can adjust the good space and check if the machine is in good position before start to use it.
Okay, so well, it's clear that here in France we have plenty of these applications. It's not maybe not so popular everywhere on Earth, but well, these machines are pretty sophisticated now. Okay, we can also make some special versions of our products.
Yes, if you have the customer, there is our standard sensor is not corresponding to the application of the customer. You can send the request to SCAIME and check if you have a solution. Normally, we can find a solution. Here we recognize the sensor for medical application. Here sensor, we take off the cover, the connector, because we need less place to use it.
Mm-hmm.
Here we have make a special fixing plate.
Yeah.
Here you recognize the heating block for outside application, outdoor application. Here it is for the sensor. We just sell the mechanic, and the customer add his own encoder. Yeah. So we make the good flange for the encoder. Mm-hmm. We propose the good coupling to make the good things. And here we just say it with the pulley. We can say the pulley just like this, or integrate pulley. We can see that
so directly fixed on the housing of the sensor.
So, yes, you can see that the direction of the cable could be very different. Normally, it's like this.
Okay.
Here, turn 90 degrees, or like this.
All right. That's interesting. Okay, so if we would summarize about the range of products. So these products are what? They are easy to install compared with other technologies. They are pretty flexible in the way that you can go from very small measurement range up to 50 meters, which starts to be quite an interesting range. And we can provide custom-made sensors on request. So for that, we just need you to define precisely what you need, and we will of course check that with our R&D and our product manager first. For the applications we are targeting mainly, but of course we would be willing to get inquiries from for any kind of industry. So industry application, of course, are the number one. Lifting is also a big business for us. Agriculture, machinery, medical, railway, wood industry. Okay, it's time for a few questions. Thank you very much for listening to us for these 45 minutes. We are probably a little bit late, sorry for that. And I'm asking to our technical team if we have questions. So I was given some information here. We have a question here. What is the delivery time, average delivery time on these products?
So the standard delivery time is 2-3 weeks, but we can make express manufacturing. It could be 3 or 5 days. It's possible. If there is only 1 or 2 units, if the customer needs 100 units, no.
Yeah, of course. Yeah, okay. Another question here. What is the rated mechanical life of a sensor?
So it depends on the sensing element used, potentiometer or encoder. With encoder, the number of cycles is higher. We can expect 2 million of cycles. With potentiometer, it depends between 500,000 to 1 million cycle.
Okay, I don't see any other question right now. I asked our technical team who says no. All right, so anyway, thank you very much for listening to us and following us. Please, if you have any further question, please ask to your usual commercial contact at SCAIME. We will be, of course, very pleased to answer your inquiries. And let us know if you have any application in the future. Thanks again.
Thank you.
Have a nice day or a nice evening or nice night, depending on where you are. Bye-bye.
Bye-bye.